So there's something important we need to find out often about matrices and vectors, how big they are. And there's two relevant functions, the size and the length. And so in all of the following examples on this slide, I'm going to be referring to this matrix M I create here. It's 7, 3, 2. Go to the next row. 7, 2, 1. Okay, so it has 2 rows, 1, 2, and 3 columns, 1, 2, 3. Right? So it's 2 rows by 3 columns. If we say, tell us the size of the matrix M, as we do here, what we'll get is a vector. It's a 2-element vector basically, and it tells us the number of rows, and the number of columns in that order. Okay, and so it tells us the number of rows, number of columns. We can do a trick though in MATLAB, and this works in general in MATLAB. Normally we're used to on the left-hand side of the equal sign, putting the variable we want to store our answer in. But if we know we're going to get as our answer, as our output of a function, a vector with 2 numbers in it, well, we can take a shortcut and on the left-hand side give a vector with 2 variable names in it. So R and C here are just variable names. And so we say RC in a vector equals the size of M. And so this size of M is returning 2, 3. We're saving it in RC. So what it does is it basically says R equals 2, C equals 3. And so that's a trick. You can basically just save multiple variables in one line with MATLAB. And so that's good for matrices. We know the size. If you think about vectors, there's only one non-trivial dimension. In a vector, one dimension is always going to be 1, because there's only going to be 1 row or 1 column, depending on whether it's a row or a column vector. So we only care about the larger dimension, the more significant dimension. And there's a function called length. And what that does is it just returns either the number of rows or the number of columns, whichever is larger. So if we found the length of our matrix M, well, 2 rows, 3 columns, 3 is larger, so it would return 3. So normally you don't use it for matrices, though. You use it for vectors, because in that case, whether you had a 1 by 3 vector, 1 row, 3 columns, so a row vector, or a 3 row by 1 column vector, which is a column vector, the length would return 3. So length is usually used with vectors, size is usually used with matrices. Right, so now we're going to look at how to access the elements of a matrix. Right, so here we're going to use M equals 732, semicolon 721 as our example matrix. We call it's a 2 by 3 matrix, 2 rows, 3 columns, as follows. And this is, all just one matrix. Alright, so first way you can access elements of a matrix, and basically in the exact same way a vector, is by giving the row and the column. You can say, I want the element in the vector, or matrix, in the matrix M, that's in row 2 and column 3. So you look here, you say, okay, row 1, row 2, column 1, column 2, column 3. Okay, so the basically intersection of row 2 and column 3 is 1. So 1 is your answer. That's the element in row 2 and column 3. You can also use just a single number to index and basically access matrix elements. So here if you use a single number, you say, I want the 4th element of the matrix M. The way it counts is down the columns. So this is your first element, 2nd, 3rd, 4th, 5th, 6th. Right, so let me do that one more time. 1st, 2nd, 3rd, 4th, 5th, 6th. All right, so this, saying I want the 4th element of the matrix M gives you 2. So using just one number with matrices, it's slightly counterintuitive. Using one number with vectors is usually the way you'll do it. So if you have a vector that's either, 4, 7, 3, 9, whether it's a row or a column vector, it doesn't matter. let's say if these are both called V, saying V4 would always give you the fourth element, whether it's a row or column vector. So you use a single number to index vectors most of the time. Okay. Another interesting thing MATLAB does is you can use the colon operator to select multiple things. Okay, so here in the, just erase everything, in the example below, right here, what we're saying is we want the element in the matrix M in row 2 and in columns 1 through 2. So, okay, we want row 2, and columns 1 through 2. So notice the intersection here is 7, 2. So our answer is 7, 2. So basically saying the elements in matrix M in row 2 and columns 1 through 2 gives us a vector. 7, 2 is our answer. One more trick you can use is using the colon all by itself, as in this final example. Colon means all of the. So here we're saying, give me all of the rows and columns 2 through 3. So we want all the rows and columns, not 1, but we want 2 and 3. So this gives us 3, 2, 2, 1. It gives us a matrix is our result. So basically you can be pretty tricky and access a whole bunch of elements at once. Okay. And we can even extend that. So we can, rather than having a colon, we can just give straight vectors. Like in this example, we're using a slightly bigger matrix called Z. That's 7, 2, 6, 3, 2, 5, 3, 2, 3, 6, 4, 2. Okay, and we're saying we want row 2. Okay, so row 2. And we want columns 1 and 3 through 4. So this gives us 2, 3, 2. Okay, so notice something interesting. We're saying, in this example, 1, 3, colon 4. Okay, so technically, this 3, colon 4 is creating a vector. That's 3, 4. And that's now inside another vector. So we have this whole thing, 1, 3, 4. But recall, a vector inside another vector, or a matrix inside another matrix, or so on, MATLAB just smashes them all together, and we end up with 1, 3, 4 as our vector. Right? So the moral of the story is you can use vectors to specify which elements you want. Right. And so now let's look at another example. And here we introduce yet something else. We introduce the use of the word end. And end is always just going to refer to the last of something. So here we're saying the row end. So give us the last row, columns 1, 3, and 4. Right, so last row, columns 1, 3, and 4. So it gives us the vector 3, 4, 2. Right? And you can also use the end keyword with the colons operator. So here in this final example, we say we want rows 2 through the end, so second through the last rows, and we want the last column. So notice the intersection of that is 2, 2. And well, so this came out formatted a little strangely in MATLAB, or rather in PowerPoint. It gives us the column vector 2, 2. Okay. So there's a lot of ways we can index things in MATLAB. Okay. Another thing we can introduce is doing basic math operations on matrices and vectors. And here we'll do element by element math. And the key with element by element math is basically both operands, both matrices or vectors, have to be the same size. They have to be the same size. And what it's going to do is basically add, subtract, etc., multiply corresponding elements. And so let's do some examples.